Good afternoon, everybody. Welcome to the video on combining functions. Now, as you can see, I hope you can see this thing. See here, folks, here we go. Now, everybody, some of this should look already quite familiar to you. The idea is to combine two functions via the operation addition, subtraction, multiplication, division. We'll learn about another one called composition, but this very first one, it says we're given a pair of functions here. We add them together and we're supposed to find the domain. Okay, we're supposed to find the domain. Now, there's not much algebra to do on this. When you add these two radicals, there's not much you can do other than just write them down. All right, and so if you take a look right down here, f plus g, folks, this really just means exactly the same thing as f of x plus g of x, right? So really nothing's happening in terms of algebraic simplification. Now this does just equal to, we'll write them down, the square root of x minus 3. Square root of x minus 3, y'all, let me get this to make sure your viewing experience is exemplary here. So we have x minus 3 there. I hope that's in focus for you. It looks like it's okay. And then plus the square root of x plus 2. Now, a lot of you who been on top of this course know that we've really already basically done this. All right, we're just doing it again for whatever reasons. Author thinks it's important, I guess. But basically, the essential idea here, folks, is to find out where the respective domains overlap or intersect. Okay, so we've seen that this domain right here is from 3 to infinity, right? Okay, you cannot input a number smaller than 3 into this function. You'd be taking the square root of a negative number, right? And in a similar fashion, the domain would be minus 2 to infinity. All right. Now, so let me, now from a number line perspective, any number greater than 3 will also be greater than negative 2, but not the other way around. So the overall domain right here is just going to be the less restrictive domain, which would be 3 to infinity. And again, y'all, the rationale here is that if a number is in this set, it's guaranteed to be in this set, right? But not the other way around. For example, minus 1 would be a number in this domain. However, it would not fall into this domain. So the actual result here is really the same thing as looking at the intersection. Y'all, I'm going to write down this symbol for you. The intersection of these two sets. Now, y'all, intersection is just a big word for overlap. And so it's the intersection of the sets minus 2 to infinity, 3 comma infinity. Now, you could draw this on the number line and see that, again, everything to the right of 3 would also be to the right of negative 2. But everything to the right of negative 2 would not necessarily be to the right of 3. An example would be 0. 0 is in this set, right? But 0 is not in this set. Okay, so this is the answer. Okay, and this represents the intersection. You know, this little guy right here is called intersection. Another word for that is, of course, overlap, okay? Now, y'all, what I want you to know is that you'll be scanning and uploading the assignment, and I'm about to tell you a little bit about that. All the assignments will be listed in the Canvas calendar as video assignment and I'll put a / upload. This is what you'll be seeing in the Canvas calendar, folks, and that is where you're going to upload your scanned work. All right. Again, it's in Canvas. There will be a due date, all of that, just like usual. You will scan it. You will not send me individual pictures. It will not be graded. If you do that, make sure you learn how to do the scan software. The majority of you guys are doing a fantastic job on that, and I appreciate you. But this, again, is the way you'll see it in Canvas. And it'll be on the calendar, like today's the 18th. Tomorrow on the 19th, you'll see this, and it will say video assignment upload, okay? Your first assignment your assignment's just going to be everything I don't work from these handouts. We'll keep it simple. If there's anything else, I'll be very explicit. So this is problem number 1 in your assignment. Okay, this is number 1 in your assignment. This is number 2. Let me go here, folks. Number 2. All of these numbers you see are what you're responsible for. Number 3, and we've already done this to some extent in our class, so it's not like you're really seeing it for the first time. You may feel that way. All right, folks. So again, these are your first 3. I normally would have worked some of these for you in class. You know how it goes. I would let you work some of the others. Y'all, what do you think this means? This means multiply, not divide. This is divide. This is multiply. I didn't give you a subtraction problem, but it's just more of the same. Okay? So let's go to the next page. Now, y'all, all of this, don't get too uptight about this. This is really everything I just said. The only example I showed you was an addition problem. But notice the answer is always just going to be the intersection of the respective domains. If you come up here, let f and g be functions with domains a and b. All right, on that last one, a had a domain, b had a domain, and we found out where they intersected. That's exactly what this means. Don't look at this and throw up. Just look at it as what we've done, except it just encompasses all of the operations. Now notice right here, you have to guard against division by 0. Okay, and we've already seen that before. Any value of x that's going to induce a division by 0 has to be excluded from the domain, and that's all this says. So again, don't let this notation intimidate you. It's just a general way of handling 2 arbitrary functions. Now let's move along rather rapidly here and get to this next piece here, which is really the new thing in the section. Okay, in this section. All right, we have this operation called composition. You see, that is not a multiply symbol, folks. That little filled in 0 is called the composition operator, and you can look right here and see exactly what's going on with it, folks. This example right here for your viewing pleasure. They call this fog, believe it or not, if you're not already feeling foggy. But fog just means to compose the 2 functions. The output of one function becomes the input to the other. So if you take a look right here, folks, look what's happening. G of x is this, and this says x cubed plus 2x cubed, right? So now, if you want to evaluate both of these, it's as simple as this. Okay, this means f at g of 4. Okay, folks. Y'all, this is really very straightforward if you just go ahead and sell out to the notation. All right. Now, what is g at 4? Okay, well, let's come right up here next to g. G evaluated at 4 means substitute a 4 everywhere you see an x. So you get 4 squared plus 2 times 4. Now, y'all check me on the arithmetic here, but this is 16 plus 8, and I'm getting 24. Okay. And y'all, if you show me your work, you know me. Let's say I made a mistake in here somewhere. You know, you're not going to lose many points just for arithmetic mistakes. But what I did is I took this 4, substituted where I saw this x, so that's 4 squared, which is 16. Put the 4 there. 16 plus 8 is 24, right? So f at g at 4 is equal to 24 cubed. And ladies and gentlemen, you're more than welcome to leave your answer just like that. Okay, this is what you'll be scanning and doing for your homework. Leave it just like that. There's no need to waste your time putting this into the calculator and tell me whatever big number that's equal to. Okay? All right, now, this is homework problem number 5 right here. And now keep track of this. This is homework problem number 5, which you will do. You will scan and upload it. Okay? Let's keep going. All right, y'all. Now, these are the ones that are probably, I guess, quote, the real problems, the ones that, you know, a little more work going on, you know, but really they're not that bad. Now, we're talking about this new operation called composition. We're talking about this new operation called the composition of 2 functions. So what I've done right here is I've created these 2 functions for you, and we're supposed to find the domain of f of g of x. All right, so let's write this down. Now, f of g of x. All right. Now, folks, right here, this is f of x, right? So this is equal to 5 over 2. Now, in my opinion, this is a very key step. Write the g of x there. Now, you could just go ahead and substitute it in right now, but you got to trust this, folks. If you're thinking about it, quit thinking. Please don't think. I'll let you know when you need to think. This is just pure substitution, right? If f of x is this thing, right, x, then f of g of x has to be this thing, right? Really, how much thinking really happened there? None. It's just rote substitution. Now, we happen to know what g of x is, right? G of x has this concrete form here, so we can write this as 5 over 2 minus 7 over x plus 5. Okay? I hope you appreciate this step. It's tempting to go straight from here to here, and a lot of you who've seen this and have the exposure to it, that's cool. But just so you'll see that this f of g business isn't that big a deal, I remember when I first saw this, sophomore, junior in high school, I was going, damn, man, God almighty. It made me sick before I couldn't even eat lunch, right? But it's really not much to it. It's just you're being a robot here, Okay, now what about the domain of this guy? Well, there is a temptation to rush and simplify this, but there's really no need to. You can already see that if x is negative 5, you have a no-no here, right? So you can already write d is equal to, we got room? Yeah, we're doing good, folks. That's a d, ladies and gentlemen. This notation is totally fine with me. You don't have to use interval notation. It's x such that, we're too lazy to write the phrase such that down. This vertical bar means such that. X such that the condition x does not equal to negative 5 has to hold, right? Right, folks? Now, all we did here is make sure it didn't blow up right here, right? That's a fraction, isn't it? And you cannot divide by 0, so we ensured that negative 5 is not a suitable input to this composition, okay? Now, but guess what? We have another bigger fraction, so let's write that down. I say bigger, 7 over x plus 5. Now, let me envelop that in parentheses. That is a denominator in its own right? This whole big chunk underneath this line here is a denominator, right? So what am I going to do? I'm going to set this equal to 0. The solution to this will be the other value of x that we have to exclude from the domain of the composition. Okay? Now, hopefully that just makes sense to you. Hopefully you're not just memorizing this and you get what's going on here. I know I was a lot like y'all. I'd go, what's going on here? And I've really found out it didn't take long. Math is so literal that it's like it has Asperger's or something, It just is what it is. There's nothing going on, not a hell of a lot of interpretation, just you got to trudge right along. So what we got right here, folks, is 2 is equal to 7 over x plus 5. Now, y'all, again, what's the goal? We're supposed to solve this thing for x and then exclude that from the domain. Or we've already excluded negative 5 here, right? So again, y'all, this is not, I wouldn't call this super interesting stuff, but it's very procedural and conceptual at the same time. So now, a couple approaches here. I've seen people just kind of eyeball this and figure out the answer, But another way to handle this more formally is just turn it over. You can write this as 1 over 2 is equal to x plus 5 over 7. Remember, y'all, if two fractions are equal to each other, we'll make that a fraction, right? Then their reciprocals are equal to each other. That's what they call an arithmetic certainty. If two fractions are equal to each other, they're equal when you turn them over or flip them, as you guys are fond of saying. So now, y'all, I'm going to try to keep my space here. I'll come down over here. Now, y'all, so what we get here is 7 over 2 is equal to x plus 5, right? Y'all comfortable there? I just multiplied both sides by 7. That's what happened. Now, this leads to x is equal to, don't be in a big rush to get, quote, the answer here. 7/2 minus 5, right? And y'all, I'll tell you right now, as I'm sitting here speaking to you in this boring room and nobody but me and all these devices, is that if you get this far, I'll give you substantial credit. Don't worry about too much here. Hopefully you know how to work with the fractions here. But this is also equal to 7 over 2 minus 10 over 2, right? Right, folks? You can write 5 as 10 over 2 to make it compatible with this fraction. All right. Now, from here, the purpose of doing that is we get minus 3 halves, right? Minus 3 halves. Now, you can actually come right back up here and check that this makes this equal to 2. If you put minus 3 halves right here, y'all can verify this on your own, but the 7s would cancel and you would get 2. Again, if you put minus 3 halves right here, this would be 7 halves. 7 divided by 7 halves is the same as 7 times 2 sevenths, but the 7s cancel, and wham, you get your answer. All right? So what are we doing now? We're going to come up here and put the sucker right here. Okay? And I hope you guys are all comfortable with this. You have a nice, patient video that won't make fun of you or tell you to, come see me in my office. Okay? You can just do this, right? You can do it and look at it at your leisure and make sure you know it cold. Okay? So y'all, this would be the answer to the problem. All right? All right, now, guess what? Let's see, what was the last one? That was number 5. This practice problem number 6 is the 6th problem on your online assignment. Okay, now, let's move on down here. This next one, actually, you'll see it a little bit in calculus. You're trying to create the 2 functions that put Humpty Dumpty together, okay? So, like right here, if you just take a look here, that would have to be this, right? The outside function just takes what we call the 5th root of something, right? So that would be your so-called outside function. Actually, it would be your outside function. And what's on the inside? Well, what's on the inside is just this thing here called x cubed plus x, right? Done. Okay. West Texas, we say done. Okay. Okay, we're done with this one. All right. And y'all, that's all there is. Read it. Read what it says. This is reading comprehension more than anything else. Find 2 functions, f and g, such that this is true, right? So there you go, ladies and gentlemen. That is it for that problem, okay? Now let's keep going here. We're making some good time. This video so far is just shy of 18 minutes. All right. Now, and y'all, these make just wonderful test questions, and you know me, and I think you've learned to trust me on this. The grades have gone up pretty good as a group. Y'all are starting to believe me. I'm not trying to fool you or screw with your heads on this. I'm giving you stuff that's very similar to the handouts. All right. Now, okay, we're just now at the 18-minute mark, so let's get going. Y'all, it's okay to specify functions as graphs. You don't have to have a formula for the function. You can specify it as a graph. So here we go. This is the graph of f right here, and this is the graph of g. Now let's take a look at what we're at number 33. Now, and y'all, I would really prefer, and I know I still have casualties on this kind of thing, go ahead and find out what g of 2 is first. That's all you got to worry about right now. Now, y'all, my old eyes are looking here at 2, and I see g at 2 right here. So what would that value be right there? That looks like 3, 4, 5, right? So this point right here is 2, 5. And y'all, if I happen to be wrong about that's fine. As long if you write that down and you mislabel it and you go based on that assumption, you'll get substantial credit. I don't think I made a mistake though, because here's 2, 1, 2, 3, 4, 5, right? So f at g of 2 is f at 5, and for the life of me, I can't get people to write this down, and they just won't. You may get it right without writing it down, but why take that risk, folks? G at 2 from the graph is 5, right? G evaluated at 2 from the graph is equal to 5. So that means that we're no longer doing f at g of 2, we're doing f at 5, which is the same, right? So now you got to look along at 5. So y'all, this is 2, 3, 4, 5. And y'all, that looks like it heads up to 4. Okay, so that y'all, that is the point. Correct. Did I go over 2, 3, 4? No, I didn't, did I? Y'all, sorry. There's 2. 2's right here, 3, 4, and 5. So 5 is actually right up here, right, folks? Okay, so would that be 6? So 5, 6 is a point on the graph, right? Y'all, again, let's make sure we're on the same wavelength here. we know G at 2 is 5. So here's, oh man, God. Sorry, y'all, I was in the wrong spot. Okay, this is 2, 3, 4, 5. All right. So that is 5, 6, but we were at the right place, right? 2, 3, I was just messed up there. 2, 3, 4, 5, right? And so that point right there would be 5, 4, right? Right, ladies and gentlemen? Pardon me for the confusion. That 5, 6 may be a useful one for you on the when you're doing the rest of these, okay? So this answer here would be 4. Now, I implore you in the politest possible terms to write this intermediate step down. Don't try to go, I can keep track of it in my head, please. I've seen so many people get it wrong because they're too damn stubborn on this, okay? So but make sure you're careful about that. Now, let's take a look at maybe F at F of 4, okay? F at F of 4. So, folks, this means the same thing as F evaluated at F at 4. And, of course, that means we have to find out what F at 4 is equal to, all right? Now, here, y'all, this is our F function, so we have 2, 3, 4. Y'all, there is 2, 3, 4. So, thank goodness I'm not in my way right here. So 4, 2, right? 4, 2. So this means F evaluated at 2. And again, I'll rant and rave anything to give you guys some extra points. Don't skip this step, please. Don't think you can keep it in your head. Maybe you can, but why take the chance, okay? All right, so now what's F at 2, ladies and gentlemen? It looks like here's 2, and 2, -2 is located right here, right? 2, -2. So this answer would be -2. Again, if you document what you're doing and mark on the graph what you're doing, if you happen to get a number wrong, you won't lose many points as far as the grades go. All right? Okay, now, y'all, we're at the 22-minute mark. At least we can keep it underneath 25 minutes. Let's go down. Y'all. Another way to do this is from the table. And I'm just going to pick one. I'll just pick number 40 since it's right here on top, okay? So this is equal to, now y'all, by the way, you do the rest of these, okay? The rest of these problems should be, all the rest of these are on your online homework, okay? Do the rest. Do the rest and scan and submit, okay? Now, I'm not going to try to number all those, but do the ones I didn't do, okay? Actually, sorry. Just, do this one, okay? Do this one and do this one, right? Okay, that's good enough, all right? So do number 35. That's easier for me to grade, and we're all happy, aren't we? I think I hear a resounding yes. Okay, so y'all, there's 35 and 36 right there, right? Do those two for the remaining problems, all right? Now, whatever the numbers are, maybe 7 and 8, I'm not sure, okay? All right, now let's go here. Let's go right down here, ladies and gentlemen, to this next one. Let's do F at 2. Yeah, this is fairly, I hate to use the phrase self-explanatory, but it really is. So here's x equals 2. That means F at 2 is 3, right? So G at F at 2 is G at 3. And I keep having these images of you guys not writing this down, so please put the 3 there and do it before you go fit. Now G at 3 is 6 from here, right? Equals to 6. And I hope you see the value in doing these just extra 10 seconds of your life to write that down. I see so many people who want to be macho and go straight from here to here. There's nothing to be gained. The risk benefit is not worth it, okay? Now, so y'all, you guessed it. I want you to do this one and this one to add to your assignment. I don't know how many it is, probably right around 10 problems. Do those two. Add to your assignment, and you'll do the work, scan and download, or upload it to me, and it'll all be right there in the spot for this will show up in the Canvas calendar. Y'all have a wonderful day till next time. We kept it under 25 minutes. Go Dodgers.